We are starting with the topic of Maclaurin series. This is Maclaurin series. Maclaurin series is a method in which a function fx, which is where x is a variable, can be expanded in the form of polynomial equation with ascending powers of x. With ascending powers of x. What it means, for example, if we start with a question here, we can say that if you are having a question, let's see here, you are having a question like this, and first of all, what is fx? For example, here now fx will be in the result of, this is f0 plus x f dash 0 plus x square over 2 factorial f double dash 0 plus x cube over 3 factorial f triple dash 0 x power 4 over 4 factorial f 4 power, and this is 0, and so on. It can go up to the nth differentiation. It can go to there. Now here, for example, you can do with the question. The question says you are having fx is equals to x times e raised to power x. You are having a question which says fx is equals to x times e raised to power x. In this particular question, first what you have to do is you have to find out the value of f dash x, you have to find out the value of f double dash x, f triple dash x, and f 4 times x. These are the values which you have to find out. Okay. Now here it is x times e raised to power x, and here we can use the method of product rule. Product rule means, you know, everybody knows about this. Here what we can do here is, first we have to differentiate this x part, which will give me 1, and ex will remain as it is. Plus in the second part, x will remain as it is, and we have to differentiate e raised to power x, which is again e raised to power x itself. What it means that it is equals to ex plus x times e raised to power x. Now for the second part, second case, we have to again differentiate it. Now it will give me e raised to power x, plus for this I will again have this whole part. Okay. It will give me e raised to power x plus x times e raised to power x. Simple. It will give me twice e raised to power x plus x times e raised to power x. Okay. Now there comes the third part. Third time I have to differentiate this type. Again I will be having twice e raised to power x, plus for this I am having this part, which is e raised to power x plus x times e raised to power x. I will be having 3 e raised to power x plus x e raised to power x. Okay, fine. Now comes the next part. Again the same method is there. It is 3 e raised to power x plus e raised to power x plus x e power x, which will give me 4 times e raised to power x plus x e raised to power x. This is the total differentiation up to the 4 terms. This is the method of doing the differentiation. We are having the question as x e raised to power x. Okay. Now the thing is here, you have to find out the value for x equals to 0. Now in the first case where we are having f0 here, this here. If we put x equals to 0, I will be having as 0 as a result. In the second case, for f dash 0, I will be having e raised to power 0, which is equals to 1, and the remaining, this part is equals to 0. Okay. Now in the third part, I will be having f double dash 0, I will be having twice times 1 plus 0 for this very part, therefore I won't use this. In the third part, third differentiation, f triple dash 0, I will be having 3 times 1, and for the fourth differentiation I will be having 4 times 1, which simply means that for f0 we are having 0, for f dash 0 I am having 1, for f double dash 0 I am having 2, for f triple dash 0 3, and for f4 times 4 I am having 4. These are my answers for f dash and for f double f dash 0 and so on. Okay, now the only thing which is left here is I have to put these values in their desired places, and on putting this value I will be having the required answer of the function fx. Now here what I can do here is, here this is fx is equals to x times e raised to power x, which is now equals to, this is f0 which is equals to 0, okay, plus x f dash 0, it will give me x times 1 plus x square over 2 factorial, it will give me 2 here, this is the number. For next, x cube over 3 factorial, it will give me 3, and for the fourth point it will give me x power 4 over 4 factorial, and here this will be 4. Okay. What it means that we are having a function, now I am writing the last statement. Now x times e power x, now understand here, x times e power x can be rewritten as x power e times x can be written as x plus, now this is equals to x square over 2 factorial, which get cancel here, and you will be having 2x square. Now here this is x cube, and here this can be written as 3 times 2 times 1, and 3 will get cancelled. You will be having x cube over 2. Okay, and for the last part, again you will be having x power 4 over 3 times 2 is 6. This is the required equation and the answer. We can write x power x times e raised to power x in the form of a polynomial, which is x plus x square plus x cube over 2 plus x raised to power 4 over 6. Okay, if you draw this graph, if you try to draw this graph, it will be somewhat like this. Just wait for a while. I have to rub this. This is a graph. I have to do it with a graph. Okay, so that you could understand what we are doing here. Okay, now what the graph of this polynomial will be somewhat like this. Okay, we have to draw the graph of this polynomial, and for drawing this polynomial, this will go somewhat like this. Okay, this polynomial graph will go something like this, and for the part x e power x, for this part, if I draw this part, this will go somewhat like this, and this will overlap this. This will overlap this. Straight line, it will go like this. What it means that if the two graphs go overlapping for a particular part, then what it means that your answer is absolutely correct. Now here in this case, you are having the correct answer, and now here you can represent that x e raised to power x is equals to the x plus x square plus x cube by 2 plus x raised to power 4 by 6. Means in this way we can convert the function which is having the variable x into a polynomial. This is the method of converting a function into a polynomial. Let's go with another example. Just wait. Let's do one more question. You are having a function such that fx is equals to under root 1 plus sine 2x. Okay. This is the question where you have to convert it into a polynomial with the help of Maclaurin series. But here in this question, some of the students might go in a way that they will start differentiating this, which is the function here under root 1 plus sine 2x. But you don't have to do all these things. First of all, you have to make it just Simple. How you can do this? We know that value of 1 is, we can write it in the form of cos square x plus sin square x plus 2 sin x cos x. We can write it in the form of this. Furthermore, I am able to see this in a form which is a square plus b square plus 2ab. This form can be converted into a plus b whole square. Okay? If you are able to convert this, then you are absolutely correct. Now here it will be converted into the form of cos x plus sin x whole square. Why? Because if you apply the formula of whole square, you will be having cos square x plus sin square x plus 2 sin x cos x. Now this square and this square root will get cancel out each other, and here you are having the function which is in the form of cos x plus sin x. You are having the function fx is equals to under root 1 plus sin 2x, which you have already converted into the form of fx is equals to cos x plus sin x. Okay, now what we have to do? We have to convert this into a polynomial with the help of the Maclaurin series up to the 4th order. Clear? Now, the things goes like this. If you have to convert this, now you have to start with each and every point. First, you are having the fx. Now fx here is cos x plus sin x, whereas f dash x, the first time differentiation. And the first time differentiation here is, you have to convert cos x, it will be into minus sin x plus cos x. For f double dash x, you are having minus cos x minus sin x. For f triple dash x, you will be having sin x minus cos x, and for f fourth x is equals to, this is cos x plus sin x. Okay, you can easily do the differentiation when you are having this function as your fx. But if you are going with this differentiation, then it will make a problem for you. Try to do the questions in a simple form so that it will help you in a big way. Now I have to find the values when x is equals to 0. Okay, when x is equals to 0, for here I am having, just to make sense, just wait for it. Now I can do something. Wait, this is, I can make it. Okay. Now here you have to do the question. You have to find out the value for f0. Now how much is the value of 0? One thing you must know about this: if you are having cos 0 is equals to 1, and you know that sin 0 is equals to 0. These two things you know very well, and with the help of these two things you can do the process here. Here f0 is equals to 1. Now f dash 0, then again here it is part is 0 and this part is 1. For f double dash 0, you will be having minus 1. For f triple dash 0, you will be having minus 1, and for f 4 times 0, you will be having 1. This is 1, 1, minus 1, minus 1, and 1 are the required values for f0, f dash 0, f double dash 0, triple dash 0, and f 4 times 0. Now, the last thing is what you have to do is you have to substitute the values here in this particular equation. Okay? Just wait for a while. Now here what we can do here is we have to just put the values. Okay? We have to put the values. Now here this is function fx. Now here the function is under root 1 plus sin 2x, or you can say it is cos x plus sin x. Now if we go further, now what is the value of f0? It is 1. Okay. Now here you have to put the value of f dash 0, which is again 1. Now x will remain as it is, and you will be having 1 with the x. Now in the third part it is x square over 2 factorial, and you will be having again f double dash 0 is not 1, it is minus 1. Okay. Now then you are having f triple dash. For f triple dash you are having x cube over 3 factorial, and here this is minus 1 plus x power 4 over 4 factorial, which is 1. Okay. Now, what you can do here is you have to just put the sign in the front. This is 1 plus x. This is minus x square over 2 factorial. This is minus x cube over 3 factorial. And this is x power 4 over 4 factorial. Okay. Now, this is the function 1 over 1 plus sine 2x, which you have converted into a polynomial with the help of a Maclaurin series. And if you will draw the graph of both the function, this one as well as this one, with the help of GDC, then your answer will be such that the sum part of the graph will overlap one another. And if that is coming, if the graphs are overlapping one another, then it is for sure that your answer is absolutely correct. Do it. Let's do one more question. You are having a fx as e raised to power sine x. This is the question. You are having the fx as e raised to power sine x, and you have to convert this e raised to power sine x into a polynomial with the ascending power of x. Okay? This is Maclaurin series you are going with. Now, this is e raised to power sine x. You have to find out the value for f dash x, which is what? For f dash x, you have to differentiate it, e raised to power sine x, and you will be having cos x. For f double dash x, what you will be having? Now, in the case of f double dash x, you are having the two functions. One is fx. This part is you can say it as gx, and this is hx. And here you have to apply the product rule for the differentiation part. Now, for the differentiation part, if I do it and I take cos x as the first one, the second function is as it is, and for this it is e raised to power sine x times cos x. Okay. Now here, if I take e power sine x as it is, and this is cos x can be converted into minus sine x. Therefore, here the sign comes of minus. Okay. This is the part where I have done f double dash x. Okay. Now it will be converted to furthermore part as it can be rewritten as cos square x, or we can take e sin x as outside, and in the bracket I will be having cos square x minus sin x. Okay. Now we are having f double dash x. Now we have to go for f triple dash x. Okay. Let's move on to the f triple dash x. For f triple dash x, I have to go with this part. Okay. Now here there are again two functions. First is the e power sin x, and the second part is in the bracket. Now what I can do here, I can simply write it the first function as it is, e power sin x. I have to differentiate it. It will give me e power sin x cos x, and this part will remain as it is, cos square x minus sin x. Furthermore, on adding this, what I will be having is, this is e power sin x will remain as it is. Okay, this will remain as it is, and I have to differentiate the part which is inside the bracket, where it is cos square x minus sin x. If I differentiate cos square x, it will give me 2 cos x minus sin x. Okay, and minus will come here, and minus sin x will be the sign of minus cos x. Okay. Now these are the 2-3 things which I can do here, but I think if I go for f power 4x, f 4x, then it will be too much length. Now it is up to you. You have to do the fourth part on your behalf. Okay, you can see that if anything cancels here, and if it's not cancelling here, then means something is cancelling here. For example, if I do here e power sin x cos x sin x, but here again coming 2, and because of this 2 it will remain here. Now it's your duty to do all this, to do the fourth part. Your homework and do this. Okay, I am doing it up to the part 3rd. Now the next thing is I have to find out the value of f0. Now here f0, when we put x as 0, we know the value of sine 0. I told you earlier in the last example that sine 0 is equals to 0, whereas cos 0 is equals to 1. Okay. Now here f0 is equals to 0. What it means, you are having e raised to power 0, which is equals to 1. For f dash 0, one thing is clear here, that if you are having e raised to power sine 0, okay, it is equals to e0 and it is equals to 1. So wherever you are having e raised to power sine 0, just put there 1. Now here this is 1, okay, and this is cos x. Cos x means cos 0, and cos 0 is again, it is 1, therefore it is again 1. Now for f double dash 0, what you are having? F double dash 0, this is 1, okay, outside, and inside this is 1 minus 0, you will be again having 1. And for the f third part, this which is I think is quite lengthy, for f third part, if you try to put here, this is 1, this is 1, here this is 1 minus 0 plus 1, and here this is minus 2 into 1 into 0, and this is minus 1, okay, here this is 0. Now what you can do here is, you can simply say this is 1, 1, 1, you will be having 1 for this whole part, and for this part this is 0, and minus 1, this is minus 1, this is 1, minus 1, again this is 0, okay. Now here it is 0. Clear? You are having the 4 parts I have taken here. This f0 is 1, f dash 0 is 1, f double dash 0 is 1, and f triple dash 0 goes for 0, for 3 parts, up to 3 here. Now the last thing is, I have to put these in the Maclaurin series, so that I could get a polynomial equation for the function e raised to power sine x. I have to make some space on the board, okay. Now, okay, what I can do here now, I have space, quite good spaces here. Now this is what I can write it as. This is e raised to power sine x, this is the main function. For f0 it is 1, and for f dash 0 it is again 1. For f double dash 0 is, this is what, 1, okay, and for next part this is 0. I have done this until this here. Now what I can say here, that for e raised to power sine x, when I go with the help of Maclaurin series and convert it into a polynomial, I will be having e raised to power sine x is equals to 1 plus x square over 2 factorial. Okay? If you draw the graph of both the functions, that is e raised to power sine x as well as 1 plus x square over 2 factorial, the graph will overlap at some point of time to an extent. Okay? This is the part of Maclaurin series. We have done some of the questions of Maclaurin series. Many questions are there. I will make another video for the Maclaurin again, and we will meet in the next class. Okay, bye. Take good care.